go ahead and record it. So any questions before we get started? We have only 2 classes left, okay? And actually, some people were saying that we don't even want this type of Zoom classes. And I said, no, you know what? Without Zoom classes, it's so difficult to communicate a course, even without, even with less amount of time. I really needed to show you some things. And that is the primary emphasis for doing that. So let me just quickly share my screen so that you will have a good idea of what's going on. So let me share the screen. Okay. So I was just trying to understand, what we have been doing for this course. And you should be looking at my Word document right now, okay? In my opinion, okay, so everybody had different opinions and people were all talking about, different angles, especially the one that we talked about on last Monday, right? Last Monday was what, 23rd? We had Taylor Wheaton. She came and said, hey, you know what? Yeah, supply chain is important. Yes, I work in logistic industry. And what am I looking into? I am actually looking into how, how drivers drive, literally, whether there are any accidents or not. And that is an important thing. That's a part of your risk in the supply chain, what type of driving lessons you are providing them, who are you employing. So that is where, the human relations, the employee training and motivation, all of them come into play. And also, one another important thing that Taylor mentioned really hit me hard. That is, yes, I learned a lot in ATI. I thought I was going to be in international business, so I took a job in Orville, but it didn't work like that. I ended up going to a different company that is ArcBest. And I love my job right now in the form of, coordinating with various drivers and, their movement of goods and how to save on, say, transporting the goods. And all of them are part of supply chain, and that is what she is doing. And what I want to emphasize there is, hey, you know what? You may have tons of goals for your future career. And sooner or later, you will find out that, oh, this is not something that I want to do. This is not something that I like to do, whether it is supply chains or marketing or your own business or your farm, running your own, farm business, whatever it is. Things will change. And so just be open to that. That is one important thing. And I did not expect that Taylor's talk will be like that, but thankfully it really give a very realistic perspective for students like you, in case if you are interested in joining the supply chain perspective. Okay, so that's the whole idea. So having said that, what did I want to tell you about this course? For me, supply chain is just like any other business course, okay? In different business courses, we take different emphasis. And in supply chains, we take a emphasis on distributors and the other people that are outside our business and how do they help us produce the product and move it to the customers, okay? So here is the picture that I drew yesterday, actually, because I wanted to kind of summarize it. So you have taken many courses in OSU, and most of you are in ATI. You take your marketing course in ATI, which focus on the customers. And you take a sales course in ATI, which focus on customer interactions. And you take a finance course or accounting course, both of them look at dollar values, okay? You take an HR course, which focus on the human beings. Then what are supply chains? Supply chains are essentially looking at your business, okay, from a different perspective through the linkages and interactions between suppliers, distributors, and all other intermediaries. Whoever helps you to produce the product, move the product, store the product, and distribute the product, all of them is the focus in our supply chains. And all the speakers that I brought in, okay, whether it is Gerber Poultry or say Freshmark, which I really appreciate. He talked about auditing the suppliers. And then, from Wooster, we had quite a few speakers, and all of them are listed here, actually, because I wanted to kind of wrap my head around this semester myself, because we have been doing a lot, and we did cover a lot, okay? And that's what I want to emphasize here. So some of the key lessons that are told by every one of them is given here on the right-hand side. I will go ahead and share this entire document with you so that you will be able to reflect on this. The very first speaker that we had was Mark Zappa, who talked about beef industry supply chains. And he told everything, that happens outside your company. What happens in Australia? What is the demand with McDonald's or, some other big buyer like, say, Burger King or like a Pizza Hut or something like that. And what are the issues? Then Melly Pullman looked at the other perspective of how to add value and how you can use your supply chains to add value. So by saying being local, by making it more like a small business where there are 3 or 4 people that are involved. And in case of Stephanie, it's actually Stephanie's, just Stephanie is the brand for her churros. And, so those kind of opportunities she talked. Then Nathan Carson talked about the global nature of supply chains, especially for chemical fertilizers. And that's the agribusiness that we are talking about. Then my high school classmate, V.S. Alagappan, talked about the loss in moving freight across international borders. And then Hannah Scott talked about cooperatives, which is a very important way how the farmers can move their goods from their farm to the customer. And then Dave Guthiel, he talked about the governmental role in managing ports, and which is very similar to my high school classmate talk on, the government also gets involved. Then Lester Charles talked about project management in supply chains. Glenn Mott talked about food safety and complaints in poultry industry. What are the records you need to maintain and how you can use your supply chains to brand. They essentially used, saying that, hey, we are an Amish supplier. We are securing our chicken from Amish and we are using it as part of their branding. We talked about that. Then Bill talked about supplier auditing in meat facilities, the temperature, the cleanliness, and he talked about cleanliness a lot because it's food products. And Taylor talked about risk assessment and management, insurance, and other concepts. Okay, so we did cover a whole bunch of topics in supply chains. That is my key message for you all. Okay, and now at an undergraduate level, you have to understand that, at an introductory level supply chains, you just have to understand these, prominent things at a conceptual level, okay? Like, oh, this is a concept, this is risk. COVID-19 is a risk and it affects us, that's good enough. But then if you go into your second supply chains course or third or fourth supply chain course, and supply chain management is a program, they have, like 10, 15, 20 courses at undergraduate level and even at graduate level. And there you will be using a lot of data, okay? And you will be analyzing data, you will conduct research. And that is what I have written here by saying, IBIS World. In the very beginning, I introduced you to this particular website. Let me click on that and hopefully it opens. IBIS World will help you visualize the supply chains. Okay, it is still thinking. It's unable to open. Why? It should open. Let me open it one more time. Okay, let me. Hopefully it comes here. Is it coming? I don't know. I am down, server not found. Oops, maybe there is a problem with OSU. Then there is go.osu.edu/procurement or procurement IQ. Procurement IQ, I think that's the one. And I was able to open it yesterday and today it's thinking. So we'll give it some time. The point here is, these databases can really help you understand your supply chains, whether it is for steel or for computers or calculators, whatever it is, you will have a lot of data, or for agriculture, food, meat, and quite a few things. In fact, the people like, Mark Zappa or Nathan Carson, Mark Zappa would be interested in the beef research reports, whereas Nathan Carson would be interested in agricultural chemicals research reports. That's what I'm trying to tell, okay? Now, as I said, at the undergraduate level, if you understand what concepts are important, sustainability is important. Sustainability essentially refers to, hey, you know what, we are making profits, but then how it will affect people, the communities that we work in, and how it will affect the environment, especially for Nathan, who is dealing with agricultural chemicals, what type of chemicals are we using and how it will affect soils and how it will reflect on our company, Chemical Dynamics. That's the company he was representing. Okay, so that is the major thing, and that's what I mainly wanted you to understand. And some of our exercises, reading and video watching, was all about that. But as I said, if you continue working in supply chains, you will be using a lot of software and data analysis, okay? And I wanted to kind of give you a little bit of introduction to data analysis. And that is where I went into this Any Logistics software. We spent about 2 classes, if I am right. And I tried to do 2 different things. The first one is greenfield analysis. So what is greenfield analysis? You have customers. So the main thing is start with customers. Okay, so that's another important lesson that you have to understand. Start with customer demand. That is one important thing that I cannot stress enough. Okay, this is very, very important. Whatever you do in whatever business you are doing, okay, and that is one reason, even in this picture, I said, you do marketing, the marketing course always talked about customers, and the sales always talked about customer interactions. And I started with customers as part of my conversation. And that means even in any logistics, you start with the customer demand. And if the demand is in different states, in different countries and different cities, then where are you going to locate your, say, production facilities? That is what we call greenfield analysis, okay? Where are you going to locate your distribution centers? Where are you going to locate your manufacturing units, right? All of them, and warehouse location and distribution center, all of that. So that is what we do. And after the greenfield analysis, we went into network optimization. So what is network optimization? Network optimization is all about how to use these distribution centers in an effective manner. Let's say there are 4 or 5 distribution centers, okay? Now, there is one distribution center in Akron, one distribution center in somewhere near Columbus, let's say. And your customers are both near Columbus as well as in Cleveland. The question is, which distribution center should be sending the product to the customers in Cleveland versus the customers in Columbus, right? Now, in this example, it's very straightforward. Akron will be selling it to the people in Cleveland, whereas the Grove City, okay, that's the example that I'm going to tell you soon. Grove City is near Columbus, and they will be selling it to Columbus. But then that's true under certain conditions. There are some other conditions where maybe Grove City should be selling to everybody. Okay, maybe you should close down your distribution center in Akron in case if the costs are high. So we need to understand, and that is what we are able to do under network optimization. Okay, so I will be talking about that in next. And then there is another important thing that I want to emphasize, that is simulation. Let us say that this is where we are going to locate our distribution center, and that is where this distribution center is going to cater to these 4 or 5 customers, and this distribution center to about 7 or 8 customers. Now let us do this over the period of say 1 or 2 years, and let us see what the costs are. The cost with regard to transport, then the profits, and also the third one is related to your carbon dioxide emissions, because we have to care about the environment as well, right? So if you are going to be like a big company like Amazon, they care about the impact on environment. What type of packaging materials are we using and how much amount of carbon emissions are happening. So let us go ahead and simulate. So greenfield analysis is one. Network optimization is we are going to figure out who is going to serve which customer, which distribution center will sell to which customer. And simulation is, let's run it for the next 2 or 3 years and see what happens, okay? So these are all the key things that I want you to know. Now, if I had reduced the number of speakers, we would have spent more time. But then, hey, this is how it happened. And I reached out to about 22 or 23 different speakers for the class, and only 10 spoke. So we should be happy, okay? I did not do entirely full and full speakers. So having said that, there are some other important things. Okay, network optimization. Let's talk about that. So what is the software doing when it comes to the network optimization? So here is a simple example, okay? And this is the major thing that I want you to understand. In case if you are to do some other course, or if you were to do the same course in Columbus campus, they will be emphasizing these type of optimizations, how to reduce cost and maximize profits. They will talk a lot about that. What happened to my Excel? It's not opening. Okay, it's opening on the other screen, so give it a minute. Okay, so you should be looking into my Excel sheet. Are you looking into my Excel sheet? Can somebody say yes or no, please? Hello?
No.
Are you looking at my camera right now?
Yeah.
Okay, so let me.
Yeah, we can see you, Professor. Can you? Hello?
Yeah, go ahead.
Hello?
Yeah, do you hear me?
We can see your. Yeah, but we can hear you, but I don't think you can hear us.
No, I can hear you.
We're talking.
Yeah, Stephanie, I can hear.
Okay, we can see your. We can't see your Excel spreadsheet.
Okay, good. So now you should be seeing my Excel spreadsheet, and I was able to hear Stephanie talking as well. And if you have any questions,
we can't see your Excel spreadsheet yet. Oh, there it goes. It looks like there's a delay in your computer.
Oh yeah, I probably too many things are kept open in my computer. That's one reason I think today I kind of went overboard a little bit.
I think it's your internet connection. It keeps saying red.
Yeah.
We did get a message on our end saying that your bandwidth was low.
Yeah.
Really? So is it still low? I mean, I was downloading some big files, and it is all over, and I think it should be okay now. I can check, the funny thing is I installed new router so that the speed will be better, but it is not getting better, it's getting worse. That's the thing. So just a minute, let me check quickly. So is the screen really bad? Is it showing or not at all showing?
It's showing. It's pretty blurry.
Very blurry.
But we can kind of make out what.
Okay, so this is what I have given, and maybe I can. I don't know how to. I can share this also on the email if you want. So let me talk about it, and then you will be able to kind of get a hang of it. So in this one, the very first line that I have written in red color font is what happens in this network optimization. So we know that there are 2 or 3 different customers, or maybe 50 customers, and they want different type of things. So since we started the class talking about Stephanie's churro, I thought maybe we'll just talk about the demand for Stephanie's churro. Let us say she started selling churro in some kind of plastic bags, that are branded, color, that she can, sell it off the shelf, not necessarily fresh that she has to prepare out of her food truck. And I just put some random numbers. Say there are about 200 customers in Cleveland, and most of our customers are in Columbus. About 500 churro packets demand in Columbus area. Why? Because Stephanie is well known in that area for churros, and she is a small business, and she is the brand, and she has a lot more contacts, so more people are buying her product in Columbus versus Cleveland, 500 and 200. So the point here is we want to sell 700 packets of churros. Now she has to decide if she is going to sell it out of some kind of a distribution center, or it could be somebody from say somebody's house, let's say. Now I just wrote Akron and Grove City as two warehouses where she can sell out of, okay? So the storage cost can be different in different places. Right now, I kept them as 50 cents per packet. Okay, and I can very well change it to say 25 cents or 30 cents. And that is exactly what they do as part of supply chain analysis, okay? They just change it to say 30 cents in Akron to store the product, or it could be only, 0.5 cents. And in case of Grove City, it may be just about 2 cents, let's say. Why? Because Grove City is a little cheaper for you to handle compared to Akron. So there are these kind of differences. Just for the sake of simplicity, we will just keep it at 5 cents both. Now, from Akron, if you want to transport it to Cleveland, it will take you about 20 cents. Why? Because it's closer, right? You don't have to travel long distance. Whereas if you want to go to Cleveland, from Grove City, it will cost you 50 cents. Okay, so they are the two numbers that I have put here in these two things. Now I can very well change it to say 25 cents and 55 cents. Okay, and if you look into the government records, they typically say a round trip mile is calculated about 50 or 55 cents per mile, okay, and that is the depreciation on your vehicles and others. So this number is more of a representative number. So it also depends on the trucks that you will use, the type of trucks that Stephanie would drive all the way from say Columbus to Akron to deliver her products to her distributor in Akron. And also the transport cost from Akron to Columbus is 50 cents, and Grove City to Columbus, it's very close. And near Columbus, I know Grove City was one of the cities, so I just chose that name. And from Grove City to Columbus, it's very cheap. It's only 20 cents. So these are the numbers. And as you can see here, these numbers are all different. And you have to vary them. And that is also supply chain analysis, okay? So I can make it 0.3, 0.6, and this one as 0.25. And this one has 0.55. So there are some small changes. And how do you know what number to put in? You have to calculate it on your own. How much time does it take? Who is going to drive? How much are you paying the driver? Whether you're paying $10 an hour or $15 an hour, everything will determine what numbers you put in, okay? So from a business perspective, you know your customer demand and you know your cost of warehousing and transporting. Okay, so these are the two major things that you can that you will know. Now, what does the software do for you? First, the software will say, okay, you know what? The software has to tell you how much of the product will be delivered from Akron to Cleveland and from Akron to Columbus. And also how much from Grove City to Cleveland and from Grove City to Columbus. So there are 4 decisions that you have to make. How much of my product will go from Akron to Cleveland and Akron to Columbus, right? Because there is one distribution center in Akron that can go to 2 customers in Cleveland and Columbus. Grove City can also go to Cleveland and Columbus. So this is something that you need to calculate, okay? So right now, let us say that this is what we call a decision variable, okay? You have to decide how much of the product will go from Akron to Cleveland and Akron to Columbus. Once you have that, now we have to calculate the transport costs. So let me go ahead and calculate transport costs. So how do you calculate transport cost? So if you are going to be transporting, okay, 1 unit from Akron to Cleveland or Columbus, okay, so 1 unit goes to Cleveland and 1 unit goes to Columbus. This is the total cost for you to transport 2 units from Akron. So that is what I have calculated here. It's all simple formulas that you will be able to code in Excel, and you have to learn Excel. And you remember Dr. Melly Pullman said this, hey, you know what? You have to learn Excel. Excel is very important, okay? But then Excel alone is not enough. That's why we went into any logistics. So any logistics that I introduced to you is doing very complicated, very advanced calculations like this. But I am trying to show you what is behind the screen, when it comes to that optimization problem in any logistics software. So assuming that we are selling, say, 1 unit from Akron to Cleveland, 1 unit from Akron to Columbus, the cost will be 95 cents for those 2 units. Now I can very well put that, we need to meet the demand in Cleveland. So I can put 100 from Akron and 100 from Columbus. And for to Cleveland, Akron to Cleveland 100, Grove City to Cleveland 100. So we meet our customer demand. Akron to Columbus maybe 50, and Grove City to Columbus, let's say 450. So we are able to meet the demand in both the places, and we will be looking at a total distribution cost of $265. Okay. Now the question is, can we do any better? Okay, $265 is what we are calculating every week, let's say, or every month. This is what Stephanie will be looking at as her total cost of storing and distributing her product to customers in Cleveland and Columbus. The question is, did we meet the demand? Yes, we met the demand, because the total demand in Cleveland is 200, and we are able to meet the demand through Stephanie's supply of 200. And Columbus is 500 is the demand, and we are able to meet the demand in Columbus by supplying 500 units. So everything is good. But the question is, this is not the best way, right? Because Akron is close to Cleveland and Grove City is close to Columbus. That means this type of distribution is not right. So how do we get the right combination? This is where you have to use something called solver that you can use within Excel. Now, there is a solver built into any logistics software as well. So you will go into your Excel, and on Excel on the top, 1, 2, 3, 4, 5, 6, 7th tab is called data. Okay. Under data, you will see something called solver. If it is not there, you can activate it by going into add-ins under the file. Okay, so you have to go into file and then options and add in and all those things. I already did it. So this data is showing up. I click on solver. Once I click on solver, it's asking me, what do you want to solve? What is your problem? What are you trying to accomplish? I say, hey, my objective is to reduce my cost. That is $265, right? That is what I have calculated, but $265 is too much every week for Stephanie to pay. So we have to reduce that by certain amount. So I want to reduce this particular cost that is coded in cell number H14. Okay. Now, how do I code? By changing what? By changing the cells K1 through K4. That is the amount of material that will go from Akron to Cleveland, Akron to Columbus, Grove City to Cleveland, Grove City to Columbus. Okay, so by changing all these 4 numbers, and how do I want to do that? I want to minimize the cost. Okay, so you can see 3 things here: maximize, minimize, or set to a particular value of $200 a week or $150 a week. Okay, I'm not going to do that. I want to minimize my cost by changing these cells. Now, there are some constraints. What is the main constraint? The constraint is there is a 200 packet demand in Cleveland, and I have to meet that demand. So that is one of the constraints. And the other constraint is there is a 500 packet demand in Columbus, and I have to meet that demand, right? Because I cannot, obviously the software will say, don't transport anything, your cost will be 0, and we have minimized the cost. We don't want that. We have to make sure that we meet the demand in Columbus 500 packets and in Cleveland 200 packets. So they are the 2 constraints. So our objective is to reduce the cost H14, that is in cell H14, by changing the 4 values from Akron to Cleveland, Akron to Columbus, Grove City to Cleveland, Grove City to Columbus, by meeting the demand. Once you set up all these 3 things, okay, so this is objective function, that is we want to reduce the cost, and by changing the variable cells, okay, the variable cells are the decision variables, subject to constraints, and you click on solve, it runs and it says, hey, you know what? I did find a solution. Okay. And the solution is better than the earlier solution. That's what they say. And the solution says all the 200 units to Cleveland should go from Akron, and all the 500 units should go from Grove City to Columbus, which is what we know, right? Based on our common sense, we know. Now the software also tells. Now let us go and see what is the total cost. Hey, we reduced it. Earlier it was $265 every week for Stephanie. Now it is only $220. Okay, so by reducing it, so we are able to reduce it by using a solver program. Okay, by coding, by calculating the cost and reducing it subject to some constraints while meeting, by changing how much you are transporting from your distribution centers to the customers, you will be able to reduce your cost. And that is what we call optimization. Okay, there are two types of optimization. One is profit maximization and another is cost minimization. And what we just did was cost minimization. That's what we did, right? Earlier, if we had randomly put different amounts between Akron and say Grove City to Cleveland and Columbus, we had a number of 265, but 265 has been reduced to 220. That is about $45 savings, right? So you do this, about 17% savings in cost. And that is exactly what this kind of software analysis can do for you, okay? And you have to learn it. Now, this is a very, very simple setup that I have gotten here. Were you guys able to see that? Were you guys able to understand it a little bit? Any feedback? I hope I'm connected to the internet. Cole, you are still muted, but I think you unmuted yourself a little bit. Can I have some feedback?
Yeah. It makes sense a little bit.
Yeah, that's the major thing, okay? And this is exactly what you will be doing if you are going to be working for Amazon, if you are going to be working for Microsoft, if you are going to be working for Ohio State, okay? To be honest with you, everybody is thinking of reducing their cost. And how do they do that? They use software like this. Now, what I showed you here was a very simple approach. You calculate your total cost, okay? That's your objective function. And you reduce it by changing what? The decision variables, that is how much from your distribution center to your customer. There are two distribution centers, Akron and called Grove City, and there are two customers, that is Cleveland and Columbus, okay? And how much should go from where to where? And we want to reduce that cost and making sure that we meet the customer demand. Now, I can very well show you one another thing. This is where you have to understand that you have to code it properly. So let me go ahead and share this thing again. So you should be looking at the screen right now. Okay, now if you do it wrongly, this is what will happen. So I click on data, and under the solver, ouch, I clicked on the wrong one. Okay, under the solver, let's say I forget to put the constraints, okay, that I need to meet those two constraints, that I have to sell the products. I have to meet the 200 packet demand in Cleveland and 500 packet demand in Columbus. I don't have those two constraints, and I click on solve. It will solve, okay, and what does it say? Don't transport anything. 0, 0, 0, 0. Because that's a way to reduce cost. Don't meet your customer demand. Your total supply to Cleveland is 0, total supply to Columbus is 0, and your total cost is 0 also. So you saved a lot of money, right? But that doesn't make sense, right? So that's why you have to learn how to code this properly. And you have to learn a little bit of Excel, a little bit about how to use the solver, a little bit about the idea behind it. And once you learn all these simple things, okay, we need to make sure that we meet the customer demand. So you have to learn how to code these things. We have to, and similarly, we have to meet the Columbus demand should be equal to this one as well. Again, here I made a small mistake actually. I put less than or equal to for Cleveland, whereas equal to for Columbus. Now, if I were to run it like this, you know what will happen? It will meet all the demand in Columbus, but nothing was, actually, I should have done it again. So let me redo this. So when I wrongly coded it, okay, it says transport 500 packets to Columbus, all of them from Grove City. But since my coding was wrong, nothing was sold to Cleveland because I had put less than or equal to. I should not put less than or equal to. I should put exactly equal to. Okay, I have to meet the demand, right? I should not be less than or equal to demand. Maybe I can go over the 200 and sell 250, try to sell it, but then, so if you were to do that, then if you do that, then you will be able to meet the demand in Cleveland and Columbus, and our cost will be $220. Okay, so this is some important thing that I want you to understand, because this is the backbone of all the optimization problems. There is something that you want to minimize, it is cost, and if it is a profit, then it will be maximized, right? We want to maximize the profit, subject to some decision variables, and the decision variables like how much from Akron and Grove City to Cleveland and Columbus. So there are 4 decision variables, while meeting the constraints of the 200 packet demand in Cleveland and 500 packet in Columbus. Now, once you are able to do all these things, okay, now you know how to handle your supply chain. And if you start thinking like that, that is exactly what people will be doing. Okay, they won't be doing it in Excel. I use Excel because Excel is very prominent. We all can easily understand the setup of a spreadsheet like that. And then I also put these arrows. Why did I put the arrows? Because once you meet the demand, and if the demand changes, then accordingly you will, the outputs will change. For instance, let me say one thing. Let us say Akron, the storage costs are really high, okay? 15 cents, Grove City is only 5 cents, okay? But from Grove City, the transport cost to Cleveland has come down because you bought a new truck, new electric truck, and your transport cost from Grove City to Columbus is even cheaper because of the same electric truck that you are using, okay? In this case, okay, let us see what happens. So maybe we'll make Akron very, very expensive, okay? 35 cents, because your Akron distributor is super upset with Stephanie, and he is going to charge you a lot of money, 35 cents per packet. And the transport cost, let us reduce it from Grove City to Cleveland even less. We will make it only 25 cents because of the electric. Now, the numbers have changed, okay? But the demand has stayed the same. Now, let us go ahead. Click on Solver. So it's the same setup. We want to minimize the cost by changing how much is going from Akron and Grove City. But we know that Grove City has access to electric trucks, which will be a lot more cost effective. Let me click on it. And what happened? Something happened. Look at this. It says, hey, you know what? If you have access to Grove City, electric trucks at Grove City should sell to Cleveland, Grove City should sell to Columbus. Akron is not needed as a distributor at all. Why? Because Akron distributor is more expensive. He is charging more for every churro packet that is being stored in the facility. And also, your costs of transportation has come down significantly from Grove City. In that case, Stephanie should have only one distribution center, nothing in Akron at all. You can see that here. Akron to Cleveland is 0, Akron to Columbus is 0, whereas Grove City to Cleveland is 200, Grove City to Columbus is 500. Now, let us look at the cost. The cost is only $160 per week. So now the question for Stephanie is, should I invest in my electric truck? Okay, from 220, now it has come down to 160, okay, under these conditions. Now the question is, there is about 40 plus 20, $60 savings every week. So about $240 per month, and over a period of year, 240 times 12, she will be able to save about $2,880. So the question for Stephanie is, should I invest in this electric truck? Make sense? So that is how you use these kind of optimization algorithms to understand what you should do as part of your supply chain. Okay, by changing the numbers of say the cost per mile, okay, from using a regular truck versus an electric truck. What is your emission for carbon dioxide? Now, carbon dioxide is something that you and I may not be interested because we are really small businesses, right? But then a big business such as Kroger or Walmart or Sam's Club or Costco or BJ's, okay, they all will be always interested because they are moving tons and tons of items on a daily basis. And they have to figure out. And some of you may know this. There is a new distribution center for Amazon in Akron. I believe it's called Rolling Hills Mall or something like that. So they have reopened a new new facility over there. So they will be thinking, what is my cost of storage in that Akron facility? And what is my cost of transport to Cleveland and Columbus and maybe, Chicago or Kansas City from this Akron location? That is what Amazon will be looking at. And that's exactly what I showed you, okay? And they won't be using these kind of Excel spreadsheets because Excel spreadsheets will not meet their needs. And that is where they will be using any logistics, or they will be using a lot more advanced software, super advanced software, which will kind of tell you how many trucks should go from your Akron location to, say, New York City? How many trucks should go from say your New York facility to Vermont, or from your Miami facility all the way to Georgia, Atlanta, something like that. And that's exactly what they are doing on a daily basis. This is what we call supply chain analysis. Okay, this is very, very important, and I want to give you a feel for that. And this is exactly what is happening behind that network optimization. Okay, so we did greenfield analysis. We placed 2 different facilities, one in Akron, one in Grove City. And after that, we have optimized it according to your transport costs. I just gave you a simple example of Stephanie investing in electric trucks and how it changes her whole distribution mechanism. Okay, now the next thing is we have to look at simulation. So what do we do for simulation? I have a couple of websites that I pulled here. So let me show you one simulation, okay? Hopefully the software works. I mean, yesterday night it worked, and today I haven't checked, and my internet is a little funky today. I'm really sorry about that. See, yesterday it worked, and today it's not opening. Okay, so let me copy this, and I am just bringing it here, and I'm just entering it here. And in the meantime, I will also type it in the chat box for you to have access to it. So you should be able to open it at your end, and you don't need to install any software or anything like that. You can just run it directly from the internet, okay? And my internet connection is unstable, unfortunately. This is the last week of classes, and I thought it would be better, and it is not. Very sad. Anyways, is it running? Okay, AnyLogic Cloud, online simulation, and it is still thinking. Oops, it's not working. Oh, come on. Yesterday night it worked. Okay, it's not working. I tried 3 or 4 times. So can I click anywhere else? Let me click on this one. Of all the days, today is the day my internet is failing. Why? I mean, I'm sorry, guys. Maybe I will show that to you at a different time. So hello? Okay, so some of the important things.
Yeah, I was just going to say, I think your whole screen and
Can
Hello?
you? Yeah, go ahead. Go ahead.
Oh, I was just going to say, I think your whole screen was frozen because I couldn't even. Can you hear me?
Yes. Yes.
I think your whole screen was frozen. Now you're all black, but before your face wasn't even moving. It wasn't even picking up that.
Oh, really? The internet is really bad.
Yeah, so it's now like your whole screen's back and it's back to like the people view.
Yeah.
We can't see your screen anymore.
Yeah, I mean, but right now I turned the camera, the screen off. Can you still see my face on the screen or not?
Not.
Okay. So maybe I will turn my camera off. That will reduce this data that I am using. And I will go ahead and share my screen. Oh, wait a minute. Which one did I share? Are you able to see my screen right now? Hello?
It's saying it's trying to like load up.
Okay.
It's loading up, but it's not showing.
Really? Oh, it's so sad. I'm just trying to close the thing so that it will. Are you able to see my screen or not yet?
Not yet.
Really? Okay. That's sad. Okay, so I will just try to say a few words because we have only 7 or 8 minutes left in the class. So some of the important things that I wanted to show you through this particular website simulations, and hopefully by Wednesday it will be resolved. My internet kind of became unstable. I'm sorry about that. Some of the important things that I want you to understand is, as I told you, we have to start with the customer demand. Okay. Now, starting with the customer demand means you have to estimate demand and you have to forecast it into the future. And there are different ways of doing it. You can use your historical analysis, historical data, and then project it into the future. Or based on the marketing you have done, you can project a new demand for your product. So that is something that you need to think of. The second thing that is given here in this particular website, in this particular Word document is bottlenecks. Okay, there is a theory of bottlenecks or theory of constraints. Now you may have 4 or 5 different things around you, and you have to figure out, okay, if I am able to run a supply chain, okay, which one will be able to support in case if there is an increase in demand, and if there is an increase in demand, which will fail first. Okay, there is actually a TV program called The Weakest Link. Now, what does it do? It essentially finds, among 5 or 6 people that are playing the game, who has the least amount of knowledge that they are holding the whole team back, right? So your team is as good as only the weakest link. So what is that weakest link within your supply chain, and what can you do to address it? That is what we call as theory of bottleneck. For instance, you may have a really big transport storage facility. You may have a really big customer demand. But to go from the storage facility in to meet the customer demand that the customers are waiting outside, let's say, outside your facility, but there is a small door. That door is actually stopping people from easily moving in and out. Okay, that means that small door is the constraint. So what are you going to do about that small door? And that is something that you have to seriously think about. And I wanted to show that to you through a simulation where, there are employees, there are forklifts, and there is storage space, and there is different things that are happening that are part of your supply chain. And if you run this supply chain for a period of 5 or 6 days, you will find that forklift is not used at all, but the storage space, you will run out of storage space very quickly. In that case, you can sell some of your storage forklifts, and you have to invest on expanding your storage space. And that is another type of thing that you will be able to accomplish by doing simulations, okay? You can identify where the problems are and you can take appropriate steps to rectify them. That is theory of bottlenecks, okay? Now, there is one another important concept, and unfortunately, you may not be able to see my screen, I think. Here I have written resilience versus efficiency. So there are two different concepts. Resilience is when the customer wants something of a particular quality. Let's say your customer comes in and says, you know what, I like ice creams and I want green color ice cream, I want blue color ice cream, and I want purple color ice cream, okay? Now, if you have all those three colors, okay, did I say green, blue, and purple? Yeah, green, blue, and purple. Or let's take simple numbers, simple colors like red, blue, and purple, because they are the three colors for the different political parties right now in the US, right? Purple is the either Democrat or Republican, red is totally Republican, and blue is totally Democrat. Now, the thing is, if you have all those three colors, okay, red, blue, and purple, then that is resilience. Whichever the customer wants, you can immediately give. But then efficiency is you have only red and blue, and whenever the customer wants a purple, you say, wait a minute, let me go to the back, let me take the red ice cream or let me take the blue ice cream, let me mix it so that it becomes purple color. Okay, so in that case, you don't have to invest in 3 different flavors of ice cream, you invest in only 2 different flavors, and whenever the customer is asking for the third color, that is purple, you are going to mix it in the back of your facility and then bring it. Now, because of that, your costs go down because you are investing in only 2 ice cream flavors, not 3. Okay, so that's something that you need to think of. So your efficiency goes up, but then the customer has to wait. Okay, now the customer who is ordering the purple ice cream may be like, oh my God, I cannot wait here. How long will it take for these people to mix colors? That's a bad idea, right? So in that case, you have to ask yourself, how many flavors do I really want to keep? How many colors do I really want to keep to be resilient? And what is the cost-effective way? That is efficiency. So the one that I just showed you in the form of Excel spreadsheets and others, we reduce the cost. By reducing the cost, let us say all of a sudden there is a big demand for churros in Cleveland, and there is no distribution center in Akron at all for Stephanie. Okay, in that case, she has to really make one more trip all the way from Grove City to Cleveland. Okay, because she has that electric truck. But then think about the amount of time she has to invest in that one more extra trip. You have to ask about those kind of things. So resilience and efficiency is also an important topic that the supply chain managers have to keep in mind. Okay, so theory of bottlenecks, that is your constraint. What is the weakest link? Resilience versus efficiency. Resilience is responding quickly. Efficiency is reducing costs. So how do they go back and forth? How do they compare with each other? And finally, you have to think about demand and see how the demand starts, and everything starts with the demand, and you have to forecast demand into the future. Are we going to use the historical values from the past, or are we going to use existing values from the current future? So you have to think about all these small things, and all of them are important supply chain concepts as well. Okay, and I wanted to share all of these with you for a long time, and since we have had quite a few speakers, I could not do that, and today I decided to do it. And unfortunately, my internet is not so stable that we are unable to get everything in. Okay, but I have kind of recorded it, and maybe at least the last 10 or 15 minutes, maybe you can watch it as a video once I upload it into YouTube, and that way you will have some good answers. Okay, and I'm planning to ask a couple of questions on this bottlenecks, constraints, resilience, and efficiency as part of your exams. So on the last class on Wednesday, we will talk about your final exam setup and a couple of other concepts with regard to managing inventory. Okay, I already showed you, but then I will show you a couple of simulations, and hopefully internet is not an issue that day. Okay, so thank you very much for putting up with me, and hopefully I am logged in, and hopefully you are logged in, and hopefully you are able to hear me. I just turned the camera on, and I don't know, I probably have to shut down my computer and restart it so that I'll be ready for my next class, and hopefully that shut down and restart will make sure that my computer comes normal, okay? I hope you heard what I just told. Any feedback? Are you guys there?
Yeah, we can hear you.
Okay, that's good. No problem. So go ahead. There is a few set of homework that is due on December 2nd. But if you have already done a good job in the previous homework, you probably don't have to worry. Your grade will not suffer. So keep up with that. And if you want to know more concepts about supply chains, please go ahead and do that. And one last thing, the SEIs, okay, the student evaluation of instruction is open right now. And I think we have 3 out of 18 students that have already given it. And I give bonus points for submitting. Okay, so we will talk about that also on Wednesday. That's our last class. Okay. So anyways, thank you guys. Thank you very much. Please go ahead, log out, and I will see you on Wednesday for our very last class. Okay. Thank you now. Bye. If you have any questions, let me know. Stephanie?